it's crazy. Okay, so when you really break it down, so look, this is the scientific, in layman's terms, basic idea of the Big Bang. Okay, so at one point in time in our universe, in the beginning, there was nothing, right? And from a single point, a single space smaller than the space of an atom, a microscopic hole tears in the universe, right? And in the beginning, there's, from that tear, from that burst of energy, a single particle is created, a single atom is created, okay? And that atom is hydrogen, pure hydrogen light, okay? And that hydrogen starts to spread, it starts to multiply. It's going through this process of expanding out from that little single point, smaller than the head of a needle. And it starts to replicate and multiply. And it's moving out because it's light, it's pure light, it's moving at the speed of light, out in every direction, all right? Not really an explosion. The Big Bang is ironic because people always, they think of the Big Bang, because it's called the Big Bang, as being an explosion, but it's not. It's an expansion of pure light, right? In this black void that we now call the universe. As the light expands and gets further away from that central point, the further and further it gets away, the more it starts to cool down, right? Just like the heat from the sun, right? If the sun were any closer to us, we couldn't exist. It'd be too hot, right? So as it gets further and further away from the source, it starts to cool down. Well, when it starts to cool down, it goes through a molecular transformation. So the effect of that cooling process on the hydrogen atoms causes them to morph, basically. They transform into helium. So they start to create particles of helium, right? Helium atoms. So now at this point in the universe, you have all this light and all this helium expanding out the speed of light. And this goes on for millions of years, right? Before anything else is created. And eventually, because of this unknown force that we can't quite explain, that we call gravity, the helium and the hydrogen particles start to collide and start to form together, right? And when two hydrogen atoms are forced into each other, what happens is, that's called nuclear fusion, right? And that's one process in which we detonate a nuclear bomb. So you take two hydrogen atoms, a hydrogen bomb, right? You take two hydrogen atoms, you force them together so hard that the atoms themselves rip open. They the force of them colliding with each other causes them to crush and rip open, and then they explode. Similar to what happened during the Big Bang. They make a mini Big Bang, right? That's nuclear fusion. So what happens is, when those hydrogen particles start to collide and go through nuclear fusion and explode, the helium gas traps the explosion, right? And then the gravity is squeezing that all together. So you have this swirling explosion happening inside this kind of bubble of helium, and the force is growing exponentially. It gets greater and greater and greater, but the gravity keeps pushing it back together. So because the gravity is pushing it back together, it's forcing those atoms into this tiny central point in the middle, and so it just keeps like breathing and growing and growing and growing. It's literally forcing its way against gravity because the explosion is getting bigger and bigger and bigger. These explosions last for billions of years, and what's happening is it's creating something. We would call that thing a star. So all of a sudden, all over this dark universe, the ding, 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 these little lights start coming on. These stars start lighting up, okay? This is where it gets really fucking crazy, okay? So what happens is whenever the star starts getting to a point that it's so massive that gravity is having a hard time containing it and pushing it back in for its particular mass. So the stars start in the very central core of the star where that explosion is taking place. The pressure and the heat get so intense that it starts to rip a hole through the universe, and the atoms start to again transform, and they sit there and they keep transforming, and they start creating each and every individual element that we know of. So it's like a little oven that's cooking the elements in the universe, right? And it sits there and it goes through all the elements on the periodic table, right? It's creating individual atoms because the pressure and the heat, like I said, it's imploding. It's crushing the center of the star. The star's mass is so heavy, it's crushing the center with so much force that it's ripping a hole in the universe. And so that's causing these atoms to transform, to mutate, and create all the other atoms, all the other elements, right? And it goes on and it goes on for millions of years. And then it goes through every element on the chart. And when it gets to the very last element, which is iron, iron doesn't conduct electricity. It doesn't conduct energy properly. So as soon as the first atom of iron is created, all of that force all at once collapses back in on itself. The star implodes instantaneously and crushes. It doesn't go out, it crushes in, blowing a hole through the universe, which we call a black hole. And that process that it's going through is called a quasar, or it creates a supernova, right? And that supernova, so the star goes, crushes in, blows a hole through the universe, and then spits its guts out in every direction, right? Spits all those elements out in every direction as far as it can, as far as it can go, right? And then that black hole that it created sits there and starts to turn, and it starts pulling all those elements, all that stardust, back in towards the center, back towards the black hole. And as all those elements start to mix together and collide and group, they get bigger and bigger and bigger. And it's like, I don't know, like taking Play-Doh and like building a bigger and bigger ball. So you have all this dust, and it's all coming back, over millions of light years. It's being pulled by the gravity of the black hole. It's coming back in towards the black hole, and it's all this stuff is mixing and intermingling and matching together and creating what we call planets, right? And eventually the planets start to latch on to the gravitational pull of other stars, which haven't supernovaed yet, which haven't gone through this explosive process. The planets, and this is where it gets really weird, right? So the planets are made up of all different kinds of elements, right? Because it's all random, it's all chaos, it's just chance, right? They have to. There's no rhyme or reason to it, One planet might have a lot more water, one might have a lot more salt, one might have a lot more iron, one might have a lot more mercury, right? So get this. So think about this. It all has to be perfect. They have to have the exact perfect amount of stuff. Because if I'm holding, a handful of salt or a handful of iron, which one weighs more, right? The iron. So the planets all have different atomic masses, is what we call it, different weights, the mass of the planet based on the type of elements and the type of atoms that planet is made up of, based on the kind of shit that it collided with and grew and grew and grew, right? And then they start to latch onto the gravitational pull of a star, right? And then other planets around it start to latch onto that, and then it creates a solar system, right? So look at our solar system, okay? Look at our solar system. If Mars got hit by a giant asteroid that was full of iron and it made it a lot more heavy, its gravitational pull would become stronger on the Earth and it would pull us away from the sun a little bit. We would all die. If at some point in time, another planet, if something came along and took a big chunk out of, Saturn, right? It would weigh so much less that it would have a much weaker gravitational pull, and all the other planets in line would move more towards the sun, and so would we, and we wouldn't exist, right? So this happens with every single solar system in the universe, of which there are unlimited amounts. There's something like, I think there's like, what is it? I don't know. Is it like 400? I think it's like 400,000 solar systems in the Milky Way galaxy. I don't know, that could be way off, but there's a lot, right? And then there's like hundreds of thousands of galaxies in each galactic supercluster, which is a cluster of galaxies. And then there's trillions and trillions and trillions and trillions of galactic superclusters. So there's literally trillions and trillions and trillions of solar systems. And in a solar system, every planet down to the last atom has to weigh the exact perfect amount. It has to be made of the exact right stuff. You know, if Earth had more helium, it'd be too light. It wouldn't exist, right? Life couldn't be created there. But if everything's just right, if every single planet happens to just be made of the exact right stuff, down to the tiniest little degree that its atomic mass is exactly the same as it needs to be in comparison to the planet next to it, right? All the planets start to balance out, and then one planet, depending again on the size of the sun and how long the sun's been living, the size of the planet, if it balances just right and it has just the right atomic makeup, it's made of just the right elements, the exact ones needed, then you get us. The fuck is that?